All right. Name two time formats used to display time on the clocks. Now, as I told you, there are two of them. You either call it analog, which is the same as 12-hour system, or you can call it digital, which is the same as 24-hour what? System. All right. But you have to remember, in analog, this is where we have AM and PM. Here, we have nothing like that. However, when it's past afternoon, the hour you add on what? 12. But the morning hours, they will remain the same until past afternoon. They remain the same until noon. Then after that, you start adding on 12, 12, 12, 12. You get the answer to be displayed in digital. All right, write down in words the time displayed on clock B. Let's go to clock B. When you look at clock B, it's a digital already together, but I want to write it in words. I mean in words, not in numbers. Let me write it down here for you to see what they're trying to say. This one, write it in words, is supposed to be a quarter to, one p.m. Oh, you can say a quarter to 1. We didn't know whether it was morning or it's in digital form. Yeah, it's a quarter to 1, as in 1 p.m. Or you can say a quarter to 13 hours. All right, because from here we are expecting 13 hours. All right, write down the number of clocks that clearly indicate a time in the afternoon. Write down the number of clocks that clearly indicate a time in afternoon. Let's come here and we see clearly. So this is one of them. B, it's afternoon. Because if it was, because it's digital, in digital midnight, it would be 00:45. You see that? But now this one's clearly afternoon. Why? It's because it's in digital format. It was not supposed to be like this one. Also, it's another one, clearly afternoon. Together. For the analog, we cannot use because we don't know where it is or what it is. Are they put AM, PM, then we'll tell. But we are only looking at digital. So it's only B and E. Write down the number of clocks that clearly indicate a time in, clearly. Take note of this, clearly. So we don't want to guess. If you use analog, you'll be guessing. So we said they said write down the number of clocks. So how many are they? There are only 2. In brackets, we said B and E. All right, please, you may pause and refer to the annexure. All right, let's continue and we see what's happening. Convert 16 hours, 45 minutes to minutes. Convert 16 hours and 45 minutes to minutes. In other words, these are already hours. These are minutes. We don't need to change them. Why? Our main aim is to have minutes. So remember, these are 16 hours. We need them to become minutes. Yet 1 hour has 60 minutes. Simply meaning, get the 16, multiply by 60, get the 16, multiply by 60. We are fighting to see that they become minutes. So 16 times 60, you get 960 minutes plus 45. So all in all, we have the total number of minutes as 1005 minutes. 1005 minutes. Hours, they became minutes. Minutes, they're minutes. You can't change minutes to minutes. So you add everything together. We are continuing. Let's see that we go through this. All right. In paper 2, we shall be expecting measurements. Actually, you're looking at measurements and conversions. All right. And assembling of objects like we see here. Illustrated below are steps and some instructions to assemble a deck chair. To assemble the deck chair, the wooden pieces are joined together using fasteners, brackets, screws and bolts, washers and nuts. These are 32. Okay, there are 32 pieces in the packet of fasteners. Each bolt is secured by a nut and a washer. So anyway, it's fine. We should not overthink about it, but you understand. One bolt. The bolt is that nail that. So one bolt, it will have a washer. That small, there's a small disc-like material. Then with at the end, you put the nut together. So one bolt, this is a full set now. One bolt should have one washer and a nut. All right, for screws, you know the screws, you just screw and it fastens the wood. Go straight forward. All right, here we go. They are saying part A, it says, so the step 1 says attach the seat using bolts, which is B, nuts E, and washer D to the front, so to the 2 front legs. Attach the long, which is A. Then we go to step number 2, which says attach the arms to the 2 front legs using the bolt C, E, and D. So here we go. We have attach the back of the seat and the arms using the screws, which is A. Together. Then step number 4, it says short brush. Okay. Here we go. Use it. Say determine the number of type C bolts used to assemble the deck chair. We are looking at C. The number of bolts. Determine the number of bolts. Okay, how are we going to determine them? Remember, they told us there are 32 pieces in the packet for fasteners, and each, remember they said these pieces of a chair are joined together and using fasteners, of which fasteners include screws, bolts, washers, and nuts. And they are telling us that in only one packet we have 32 pieces. So let's come down here. When we look at this, when we look at this bolt C, they are missing. Numbers are missing here. So in other words, we need to know when I add my 8 screws plus my 6 bolts plus my type C bolts, which are not there, I will leave it as C, plus my D, which is 8 washers, plus E, which are 8 nuts. I should get the answer as 32. Where am I getting 32 from? From the scenario. A pack consists of 32 pieces. All right, when we add this very well, we shall end up saying that the answer that we have is 14 plus 8 is 22. 22 plus 8, you get 30, which is this means this simply means we have got 30 bolts plus C should give us what? Should give us 32. All right. So having done that, but when you add 30 plus C, what you get 32. So meaning our C is supposed to be 2. Our C is supposed to be 32. All right, state the number of nuts left over after step 1 is complete. Step 1, let me see. Step 1, what does it need? Step number 1 needs attach the set using bolt B, bolt B, nut E, and washer D to the 2 legs. So here we are. Let me see. And the A, but they're saying here, the question asks us, state the number of nuts left after step 1. Step 1, how many nuts does it need? You understand? We have the type E nuts, but how many of them? We shall have, let me see here, we have E again. We shall have 6 nuts. 6 nuts, because here we are. We have, let me see. Attach the stitches. They never told us how many nuts are inside here. But anyway, we shall take it to be, here you take E, 1 E. Also this other side you take E. So of the 8, you've taken off 2, because of these 8 nuts, you've taken off 2. So how many do you remain with? 6. 6 what? Nuts. Name the last piece required to complete the assembly of the chair. It was already named here. The last piece to it's this A. This part here. The short brass. So short brass. All right. 1.1.3. We have a map here that we need to look at and analyze. All right. They're telling identify the type of scale used. The scale is this one, which is here. Together. This one, whoever said a bar graph, a bar scale, sorry. Whoever says a bar scale, my friend, you're right. No any other. Guys, please refrain from guessing. Find someone saying a map scale because it's on a map. No, it's called a bar scale. Also, someone who says a line scale to be fine, but the right answer is supposed to be a bar scale. Name the province that lies east of Northwest. Remember, the map, what is it about? Or what is it for? It's for the Northwest. Yes, so definitely, Northwest cannot be east of Northwest. You understand? So they are saying, name the province that lies east of Northwest. East of Northwest. So first and foremost, look for a compass. If it has no compass, we take it by the compass is here. Simply meaning, it's like this now. The compass. This is the compass now. So we have north, south. This side becomes what? East, and this is what? West. So we come here. So we are supposed to look on this side here. East of north, west. So here I say Gauteng. This is Gauteng, but then this is east. What about north? Because if this is northwest, and we are looking for that lies. They said the province that lies east of northwest province. East. So we shall say it's what? Gauteng. It's directly there. It's Gauteng. Gauteng lies east of northwest. All right. Identify the national roads that passes through Freiburg. First and foremost, identify the place. This is it. This is Freiburg. So we look for national roads. We have N14. It comes here, it continues as N14. Here we have N17. N17. N17, which is this, N14. It's around what? Freiburg. All right, those are the steps that we see. So they pass through. So they said, identify the national roads that pass through Freiburg. So we say N14 and N17, as we saw it on the map. All right, I'll write down the number of destination towns / cities shown on the map. There's a number of destination towns / cities shown on the map. Now, if you don't know that, most questions they have a key together. So they're saying write down the number. They didn't say mention, but they said write down the number of towns / cities. So what we're going to do, whatever word we find in this box like this, you just know it's a destination town or city. So here I have my friend 1, the other one's called 2. We have 3. Come down here, count that 4. We have 5, 6. We have 7. All right, someone might think of Pretoria. No, yes, it's there, we see it, but it's not in that box. Together. Another thing, someone might think of the N4s and the N. No, these are roads. They are not destination what? Towns. So we have 7 destination towns / cities. 7 destination towns or cities. That's it. Okay, here we go. Unfortunately or fortunately, we are not using any ruler. But if they say measure in millimeters, my friend, here, this is when you pick your ruler. Pick your ruler. When you pick your ruler, please you measure the distance as they have told you. Now, in brackets, I've said as the crow flies. So in simple terms, here they don't want you to use the string or the thread. Here use a ruler and it will be a straight what? A straight line from one point to another. Now here they're saying as the crow flies from Blue Mouth to Leichenberg. Together. So you come here, identify the towns. We are here. Together. Then we are going to Leichenberg, which is this one here. The place is here. Ne? So put your ruler here up to here. Measure the distance that you get. Measure the distance that you get. Measure the distance that you get. So now what you're going to do, what you do now, it's I'm going to just show you here something small. All right, you get your ruler. Then you measure from this distance here in a ruler. Please, with a ruler, sorry. You measure it from this place to this place. So let's imagine you have approximately, they said measure in millimeters. So you write it, approximately you have 12 millimeters. Yeah? So you come here down. No, this is too much. It's probably, let's say you have 50. If you've got here 50 millimeters, You come down here and you measure it just right, and you say 50 millimeters. You use your ruler there, please. All right, let's look at question number 2. Question number 2. Question number 2 talks of the annexure. Get it, please. What we see, it's what they want us to look at. So we are looking at question number 2.1, annexure A, which is 2.1. All right, it talks of a sitting plan, I believe, and as you show it, as you see it, annexure A shows a restaurant sitting plan for customers. Use the information on annexure A to answer the following questions. Give one possible reason why this restaurant has so many windows. One possible reason. This is simple. Number 1, to have fresh air. You understand? We need fresh air, air circulation, air flow. Number 2, to have enough what? Enough natural light. You understand? And if you have enough natural light, guess what happens? You don't need to switch on the lights. In the end, you cut on electricity. All right. Someone might have other reasons, like for easy fire what? Fire, for example, in case of fire incidences, it's easy for customers to exit instead of them using one small exit. Others can jump over the windows, and an easy way of escaping. All right, calculate the maximum number of chairs available for customers. Let's go to our next chair. The next chair is here, and numbers available for customers. Please take note. How many tables have 4? We have 1. We have 1, 2, 3, 4, 5, 6, 7. So this, remember, we're looking for the maximum number of chairs. So only these ones that I've ticked now, they are 7 tables, but each has 4 chairs. So those are 28 chairs. Keep them aside, please. Let's continue. How many tables have 1, 1? So we have 1, 2, 3, 4, 5, 6. So these are 6 what? Plus 6. We are going to add on. How many tables have 2? 2. It's only 1. So plus 2. Plus, how many tables have 3? We have 1, 2, 3, 4, 5. So it's 5 tables with 3 chairs. How many chairs are they altogether? 15. So what? 15 chairs. Plus, what's missing here? What haven't you ticked so far? We talked of chairs. We cannot count couch. All right? We're only looking at chairs. So here, the table number 18 has how many chairs? It has 6. Together. So table number 18 is the last one. All right. Someone might have seen the number of tables, 21. You get 21 and say, there are 21 chairs. No, we are counting chairs that are available, maximum number of chairs. So we've seen it's 50, it's 28. 28 plus 6. I think 28 plus 6 plus 2. 6 plus 2 plus 15 plus 16 plus 6, sorry. Plus 2 plus 15 plus 2 plus 6. No, there's none of that. It's just like this. So 28 plus 230, 36 plus, say, because I say 20, then here only it's 36. 36 plus 15 plus 6, you get 57. So we have 57 seats available for customers. 57 chairs, by the way. Determine the number of seats directly facing the wall on the south side. Let's go back to our next chart. So if you hear south side, so first and foremost, look for the campus. Together, the campus is not there, but they have given you here the main entrance doors are on the south side of the building. So definitely you have to look for the main entrance. So if the main entrance is here, so you're looking for chairs that are facing the south. Here we shall count them critically, or let's go and take note of the question they are saying. Name the number of seats that directly face the wall, the south side, directly face. Here we shall have, I think, two answers. Directly, so we have 1, 2, 3, 4, 5, 6. Yes, 6 what? Chairs. 6 would be okay. 6 seats. Or you say 6 plus. I'm going to show you something small here. This is facing the south hall. This is facing. Come to this one here. Come to this one here. Another one. Look at this one. What about this one? You see that? So we have 1, 2, 3, 4, 5, 6, 7. They are all facing the south. The south directly. Not because these ones can't, but this is diagonal. We can't count these, but these ones are directly facing. So we can say 1, 2, 1, 2, 3, 4, 5, 6, 7. So I believe also that one who says 13 chairs, it's to be fine because we are adding all those 7. All right, let's give one reason why the restaurant has couches at the entrance. Definitely now the couches will be used by those ones who are waiting for takeaways, I believe. You see that? Not for customers who are waiting for their orders to stand in the queue. You know, it confuses. For example, if you go to KFC and you find people waiting to collect, there will be also lining, as well as those ones waiting to order. So it confuses a little bit. But if someone is waiting for an order, let them have a seat. Then you know what? I'm left with these ones to serve. So the couch are for those ones who are waiting to take their orders. Give one reason why a restaurant has couches. Give a reason why a restaurant has couches. So here we go. 2.1.5. A person at the table 18 leaves her seat and walks towards her friend at table 4. She uses arrows. She uses the arrow path shown on the seating plan. Use the compass direction to describe. Use the compass direction to describe the path from table 18 to table 4. Use the now when you hear compass direction, what comes in your head? You need to mention north, you need to mention east, you need to mention west, you need to mention south. At the end, you're looking for news. Are together? So let's go there and we see table 18 is heading to table 18 is heading to table 4. Table 18 is heading to table 4. Let's go and check on their next year. And next year, and next year. Let's look at the annexure. All right, the person is in table 18 here. But okay, the person is going to use, they said use the arrow direction. At the end, they're also using the compass. So the compass, remember, this is north. So this is what? South. Why am I saying that? Because they told me the main entrance is found at the south of the building. So the person, table 18, they will move in the southern direction because they need to move like this. They're saying describe. They move southern direction. You move in the southern direction, or you move south towards table 7, pass table 7, then turn east. Turn east. Turn east. Having if you turn east, the third table on your left, that will be the person, because this is table 4. Person is coming from table 18. So south and east. Right? But if at all they are not said, use the compass direction, this would be the person stands up, he moves towards table 7, he moves towards table 7 here, which direction is that? We can't, it's straightforward. Because if a person was seated here, he definitely has to leave the table, come onto this line, then he moves down. As he's moving down now, this is his right and this is his left. For you, this is your left and this is your right. But for him, his left would be here, his right would. So he will come here. So he will turn left after table 7. Then the person will be on the right-hand side after turning. All right. Let's continue. We look at question number. NOM claims that there are less than 21 tables for customers in this restaurant. State a reason why, whether her claim is valid. Right, let's go and we say annexure. Let's see if there are less than 21. Indeed, there are less than. Let me see. I'm going to count them. So we have 1, 2, 3, 4, 5, 6. Yes, these are 6 tables. 7, 8, 9, 10. Yes, 10 tables. 11, 12. Yeah, 13 is missing. 13 is missing. 14, 15, 16. 16. 17 is there, 18 is there, 19, 20, 21. Yes, there are 20. 13 is missing. There's no 13. Together? So we say there are 20 tables because the 13th table is not the 13th table, or table 13 is missing. Table 13 is missing. State the reason whether her claim is valid. It's valid. State with a reason why. State whether her statement is valid. Yes, there are 20 tables. The 13th table is what? Missing. It's not there. All right, let's look at the next chart B. Look at the next chart B. Next chart B, probably when I look at it here, I see a tree diagram. A tree diagram. Why do I say tree diagram? This is probability. A tree diagram because I see options. One protein, chicken. You take one of the, all of these are proteins, but you take only one. Then one side order, vegetables or salads. That's you pick one. Dessert, it's either ice cream or pudding. You understand? So that's why I just look at it and I see that it is what? This is probability. And they're asking which type of diagram is illustrated on the next year B. Let's go to the next year B and we see. And next year B, here we go. All right, this is the next year B, and as I guessed, is probability. The kind of diagram that we see here, it's called this is called a tree diagram. This is a tree diagram. These are the branches. These lines that you see, those are the branches. Together? By the way, we have no leaves and we have no stems, but these are the branches. We don't have roots. I think the roots would be these numbers that we see here. Anyway, look at this. As you see the table itself, as you see the diagram, the tree diagram. This represents the first chance, the second chance. Together, this is the second first chance. Sorry, it's this one here because here we're supposed to also have a tree, as in it has to be coming. So this one is the first leg. This is the first leg. So this is the first leg whereby they had to come together. So here they need to come together like that. So that's how it is. So in case one is missing, for example, this one here, you will have to work backwards. For example, this, let me see, this is 2.2, 2.2a. They are missing. Anyway, we see that this combination was got from here. They began with a certain letter, which is F. So here it's supposed to have F. F, V, I. F, V, I. Let's come here. F, V, M. F, V, M. So F is supposed to be here. Let's guess. Someone give us the answer here. The answer here is supposed to be, now look at all these combinations under this. They all start with C. Definitely your answer is supposed to start with C, which is this one here. But it's at the last place here. So it's C, goes with S, and it ends with M. So C, S, M. That's supposed to be the answer. This is the tree diagram that we are looking at. That's how we get the combinations. Last example or that solution that I'm giving. Let me see, we have, for example, how did they get this? They took the B, wonderful. They took the V, wonderful. And they ended with M. So the branch went like that. Then it collapsed like that. Are we there? That's how we answer. Please never leave such a question unanswered. All right. We consider them to be free marks. We continue the other question. You see what other question are they saying? We've already completed this. They're saying name the type of diagram illustrated in Annexure B. I've already told you it's called the tree. The tree is called the tree diagram. Write down the missing outcomes. We've already seen them from the annexure, which were A is CSM, A, CSM, and the B was F, fish. Say the number of combinations with beef as proteins. These ones are 4. There are 4 combinations. Let's go back to the next one. You see beef, which is B. It has split here, and look at where do you see B only? So you have 1, 2, 3, 4. So these are the 4. These are the 4 combinations that we have. The other question has to be, or it was, determine as a percentage the probability of randomly selecting a meal with pudding as a dessert. Now, what we're going to do, this is the sample. So probability will always equal to sample over the population. Sample over the population. Now, what's the population? The total outcome, the chances. Together? Then a sample, part of the population. Many of you have gone to supermarkets and you've seen that they're giving you, they will tell you that these are samples, simply meaning it's not a full pack, it's not a full package. They give you something small. So a sample is part of the population. All right, let's go there and we see. The sample you're looking for, it's the M. Are together? But out of what? How many outcomes do we have? Here we have 4 of them. Here we have 4 outcomes. Here we have 4. Also here we have 4 out. I'm counting these outcomes here. Are they? Then having counted these outcomes, so all in all they are 12. So population, my population is 12. Of these 12 chances, how many combinations have M? How many combinations have M? I'll start with this one. This one has M1. This one has M2. This has M3. This has M4. This has M5. This has M6. So out of the 12, we have 6 chances that someone of picking someone who has taken OD. So we shall say it's 6 out of 12. They say determine as a percentage. So what do? We multiply by 100. But I'm here seeing 6 over 12 times 100. Your answer, it will become 50%. Why did I multiply by 100? They asked me to determine probability as a percentage. And I went ahead, I used the probability method, which is sample over population. But because they need a percentage, I multiply by 100. Out of my 12 chances, I have 6 which I'm sure of. Over 12 that are all the ones. And I multiply by 100, I end up having 50%. 2.3. Below is a simple route map of Los Angeles Marathon, LM, in the United States of America. LM, it's 26,2 miles. All right. By the way, the moment I heard of America, guess what came in my, remember we have two systems of measurements, ne? We have the metric and we have what we call the imperial. The metric, it's what you use in South Africa, kilometer, meter. We go to centimeter and millimeters. Whereas imperial, we'll start looking at miles. After miles, we look at yards. After yards, we look at what we call feet. And we shall look at inches. This is imperial. And together, let's keep that in our heads. For metric, they'll always ask you to provide the values. But for imperial, they will always give you the conversion factor. Anyway, keep this in your head, 26,2 miles. Okay, here we go. They say explain the meaning of the route map. This is straightforward as you look at it. The route map only shows, or it shows the way people who are running will follow. You understand? Route. Which route are you going to take? Together? Remember, this is a marathon whereby people run in big numbers over over long distance. Together. Marathon, we also have what we call the cross country. I think the cross country is in the countryside, right? Whereas a marathon, even marathons, I also can. No, cross country is a longer one. Eh? Anyway, map not on scale, simply meaning the measurements are not perfect that much. All right. Describe what's meant by the map not on scale. Together? In simple terms, it's not actual. I understand? The measurements are not actual. It's not on scale. Runners in El Marathon have passed the underneath a bridge at a certain point during the marathon. Explain how this is indicated on the map route with no route line. What do I mean? Take note here. There's nothing there. Even here, so simply means they are passing under the bridge. Even here. You understand? Here, they pass under. That's why the route is not indicated. As you here, you see it's clear. But here, it's under. That's how it's indicated. Come here, it's under. Come here, it's under. Also here, it's under. That's how we know that this guy is passed under the. Then this one here would be like a subway. Or a subway, what do you call it? A tunnel. Or lanes. Anyway, let's go and see. Write down the number of times that runners who completed the marathon will pass underneath a bridge. So that I was looking at. I said, how many times? So let's count this as 1. We come to this, we call it 2. Come to this one here, 3. And this one, we have it as 4. Any other part where the marathoners not, it's not clear. Probably 5 is something here because this is a start. This is an arrow. There's nothing there. So we go on and you see 5. There's no any other place. All right, this is 5. 5 times. Write down the general direction in which runners will face when they start in Flower Street. Now, when we look at general direction, please take note. General direction, you are not describing any route. General direction, what has to come in your head, it's the compass direction. Some people call it compass. Together? The compass direction, the north, east, west, and the south. That's what we're looking at. So let's go there and we see they said, write down the general direction in which runners will face when they start running. Now, before you give the general direction, you have to look for the compass. Now, here the compass points at this side. Look at the end. So simply meaning up there. So this side is what? East. This side is west. South. On top here, it's what? North. Together. So where are they facing? You come here. Try to draw the compass and look at where they are facing. South, west. South, west. Avoid writing shortcuts, but you should write it in full. All right. Question number 3. Here we go. These are measurements. Look at measurements. We look at area, perimeter, volume, surface area. Okay, that's wasting a lot of time. Let's look at this. Let's analyze actually the box and we see. Every learner in a technology class is expected to have pre-stick and pretty glue sticks. The pretty is packed in a rectangular box, sleeve, and the pretty is in a cylindrical container. So here we go. Rectangular shape. Here we are looking at it. So we have 2 shapes here. 1, rectangular. 2, cylindrical. All right. The dimensions of the rectangular face of the pretty sleeve and the cylindrical pretty containers are given below. All right, pre-stick and pretty glue stick together. This is called a glue stick. The people call it pretty. All right, and we go on. Okay. We have definitely for a rectangle, you expect to have length, which is L, width, which is W. Most cases, we also need height, if it's a 3D together. Then a cylindrical, we only need the diameter and the height. This is already 3D. There's nothing much that you need to do. All right, there we go. It's calculate the perimeter of the front of the pre-stick. Number one, pre-stick sleeve. So it's this one here. So the perimeter. So simply mean, what's perimeter? Perimeter is the total distance around a given shape. And they've given the formula. Please, once they've given the formula and you indeed know that's the right formula, just continue, substitute in it. So we shall start with a 2 times, open brackets, length, 239, plus width, which is what? 89. Make sure that all of them are in the same units. So they are all in the same units. I need to go ahead. So having done that, your final answer becomes, don't forget the units, 656 millimeters. Millimeters. Okay, here we go. They tell us to calculate in centimeters. Take note of that. Calculate in centimeters the height of the opening / the closing part of the pretty container. We come and we see it here and we see, look at that. Look at that. This has parts together. Oh, the cap, yeah. The cover. The height of the opening / the closing part of. So it's the bottom part, this one, which is dark here. So we need to know. Okay, they're saying calculating the height. Oh, okay, it's so simple. So what is going to be? Look at this. So simply meaning, when from here up to there, let me call it O. No, Q. Let me call it Q. When because I don't know this, I'm calling it Q because I don't know it. From there up to there, it's Q. So when I add my Q plus my 7 plus my 2,5 centimeters, I should end up having 114 millimeters. But look at this. These are centimeters. Also, this has to be in centimeters. But these are millimeters. What you're going to do, you're going to change the millimeters to centimeters. So I need to change my 114 millimeters. I need to change it to centimeters. How do you change millimeters to centimeters? I will need to divide by 10. I'll need to divide by 10. So here I end up having 11,4 centimeters. I've changed this, but it's not the end. So we are saying when I get my unknown number plus my 7 plus my 2,5, they should give me 11,14. All right. So here when I add this, I end up having my Q plus 9,5 equals to 11,4. But I'm looking for the Q. Which number do I add to 9,5? I get 11,4. So my Q now become 11,4 minus 9,5. 11,4 minus 9,5. I end up having my answer as 1,9. We said we shall take the total height the total height has to change to centimeters because they need my answer to be in centimeters. The total height, which is 114, we shall divide it by 10, get 1,4. So when we add these other areas, they should give us this. When I add my unknown, add plus 7, plus the 2,5, I should get 11,4. Simply meaning this has to be 7 plus 2,5 plus the unknown. When I add these two, I end up having 9, I end up having 9,5. So I will say 11,4 minus 9,5 equals to Q. Equals to, please take note of that, centimeters. The actual height of the glue in PRET container is 8,5 centimeters, and the volume of the glue rounded to 30 decimal place is this much centimeters cubed. Show by calculation that the volume of the glue was calculated if the diameter of the glue is 28 millimeters. The actual height of the glue so the glue inside the container is 8,5 centimeters, and the volume of the glue rounded to 3 decimal places, it's this much. So we need to we need to show that the diameter is this much. But look at the formula they used. You understand? But in your head, because you're determining the diameter, you know very well the diameter is got from you getting the radius and multiplying it by 2. Together. So you're going to use this formula, you're going to use these values here, and the volume and the height of the glue and the formula to get the radius together. So this will be my volume, yes, which is 52,346 equals to 3,142. Do we know the radius? No, but allow me leave it as r squared times, do you know the height? They told us it's 8,5. So we multiply the normal numbers and leave the r squared alone, which is 3,142 times 8,5. You get 26,707. Please, I will leave the number the way it is. I won't round off. Let me do it from here. This is part B. Volume equals to pi r squared h. Remember, they've given us the volume already. The volume was given to us as 52,346. So 52,346 equals, when you multiply the pi and this number here with the height, and having 26,70 times the r squared, because the r is missing. So what do? I need to divide through by, there's a comma here. I need to divide through by 26,77 on both sides. On both sides, so it becomes 5,346 divided by 20. So when I do that, this will die with that. So I remain with my r squared equals to 1,96. So what do? I need to look for the radius, which become the square root of this, square root of my answer. Yes, indeed, I remain with r equals to 1,14. But remember, we are not interested in r, but r will help us get the diameter What do? Multiply by 2 and times 2. So I end up having, these are centimeters. The proving is in millimeters. I need to multiply by 10. Indeed, I've done it. So this was the answer. This is part A. Part A. Part A. Looking for the diameter. What I would advise you to do, let's look at this. Volume of a cylinder will always be pi r squared. So this we can put it in the triangle like this. Volume equals to pi r squared h. So if I'm looking for, definitely pi is a constant number, there's nothing much there. So if I'm looking for h, height, it will be height, yes. What am I remaining with? I'm remaining with volume divided by pi r squared. So simply meaning if I'm looking for height only, height, what am I? I'm remaining with this. So which will be radius squared equals to volume pi r h. But this is squared. So what do? Whenever it's squared, we need to apply square root. So we need to apply the square roots on both sides. That's how we do it. This is how you remember these formulas here. If you ask for radius, square root of volume divided by pi r square pi h. Whereas if you're looking for height, it's volume divided by pi r squared. So definitely if you're looking for volume itself, it's the bottom part, all of it. That's how we remember those. That's how we remember the formula. Okay, we look at the second question. It says, determine and round it to the nearest gram mass of the glue in the pretty container if the density of glue is 0. So density here, they have told us that density, the formula is here, density equals to mass divided by volume. So we determine the round up to the nearest gram, the mass of. So we're determining mass. Mass simply meaning it will be density times what? Times volume, which will be density, they have already told us is 0.82 times the volume of the glue, which is already what? So the mass, they said it's 442.92 grams, but they said round off to the nearest. Take note of this. So here it's 93 what? Grams. Why did I multiply? Because this one here, in actual sense, it's density equals to mass over volume. You are interested in mass. What happens? M will remain and the D will multiply with the V. All right. Mathematical literacy, others call it mathematical lit or maths late. Anyway, yeah, we shall be working out of 150 marks. Everyone knows that, 150 marks. Of these 150 marks, that they will be turned into 100%. For you, remember this 100% is the one that will determine your level.
either level 7 or not. So from 150, we expect you to have 83 marks. The moment you have 83 marks, you have 55%. And this will come from measurements. Then 40%, this will come from maps and plans. 5% probably it's the probability. 5% it will be the probability. Now, when you add these, you end up having 150. And when you add these percentages, you end up having 100. All right, let's see how it's split. Remember, the topics that we have in paper 2 are measurements, maps and plans. Maps and plans, don't forget maps and plans. We also include the scales and other representatives. Probability cuts through. This one is in both. It's in both. It's in both papers, paper 1 and paper 2. All right, let's go into that. Now, the structure of the question paper. When we look at question number 1, it will have 30 plus or minus 5 marks only. Taxonomy level 1. This simply means these are the simple questions. Please do not leave question 1 unanswered. Do not leave question 1 unanswered. It will have a mixture of maps and plans, and measurements. When you look at measurements, we shall be looking at the area part of it, the conversion, perimeter. We look at volume, you understand? Conversion, changing from meters to centimeters, kilometers to miles, all right? Those simple parts. Then we look at question number 2, which is based on maps and plans. Maps and plans. When we look at the plans, here we shall be looking at the floor plans. The floor plans. The structure plans, the layouts, like the shopping mall. All right. Probably we shall also look here. We expect to see something to do with the sitting plan. Sitting plan, we see it in examination rooms. We see it in a stadium. We can see it in a movie hall, cinema hall, planes or bus sitting plan, how people sit. All right. Measurements, again, this is question number 3. We'll be looking at only measurements. Question number 4, it becomes integrated. Question number 5 becomes integrated. All right. When we look at this question, for example, this is an annexure for question number 4. This is a floor plan, and we expect this to be in question number 2. All right. If it first comes in question number 2, you have it in question number 4 or 5. Then when you look at measurements, we look at parts of, you should come knowing these formulas, because we expect them to be off head. These formulas are supposed to be off head. All right. Volume. Now, this is for a rectangular prism. That's volume of a rectangular prism. When you look at this, side times side, this has to be cubic because all sides are equal. It's a cube. Then volume of a cylinder. Why am I saying a cylinder? Because I've seen radius. All right? Radius. So you should know these formulas here. All right, how to pick them. Then when this is question number 1, remember, question number 1 is also integrated. It looks at measurements and maps and plans. Look at this here. They're asking identify the 3-dimension, which is 3D shaped, that is indicated by A. When you look here, you see A. These were these seats. All right. The round seats, The diameter of a page is this much. Now, listen. You see like this. These are simple. They want the diameter is in centimeters. Take note of that. They want the answer in meters, and they want the radius. For you, they have given you this is this. What they want is this. Remember very well that radius will always equal to diameter divided by 2. So this has to be 400 divided by 200 centimeters, of which we divide by 100, we get our 2 meters. You see, 2 marks got just like that. All right, so we expect you to know how. We expect you to know how to change these metric. You know, remember these are called metric units or metric system. All right, that's what we remember. We expect to see such questions. Yes, in the question 1, the type of map. Yes, this could come in. But then when you look at question number 1, it's so obvious that the answers are taken from the next year's given to you. All right, that's why you see in most cases there are 2 marks per question. All right, please don't hesitate. You show working where it's needed. All right, you see, it's rare to see. You see, there's a 3 mark here, a 3 mark question. This is it. So it means you need to do more work here, but it's not that much, you know. This is straightforward. From the next year, you give the answer. The dimensions, you know this. These are the measurements. For example, length. You can look at the breadth or height. Those are the measurements. So here they're saying write down the imperial measurements or imperial dimensions of the length of the small double bed in words. You know, so you give the answer in the words. So, but these are the imperial ones, will be the ones on top. For example, look at this. This is imperial. These are feet. Together. Then down, this is what we call metric. Metric, the ones that we usually know. The centimeters, meters, kilometers, millimeters. Those are metric. But then when we look at feet, inches, that is, or those are in imperial. That's what they're trying to tell us. All right, now they're saying write down now. What are you writing down? The dimensions of the length of the small double. So the small double. So you're writing the length. The length is the longer side, which is this. So they want you to write it in words. So it's 6 feet and 3 inches. So you write it in words and you say 6 feet and 3 what? 3 inches. You know? All right, let's go to the second question. Let's try and see. Now, when we come back here, we look at question number 2, maps and plans. This would be probably question number, it will be maps and plans, the floor plans, you know. Let's check on our question number 2. You see, they send you to a next year. But this one, it was a district plan. A district map, all right? A district map. You see that? So maps and plans. You should know the types of maps that we have. The regional, the provincial. We have the ones for the street map, you know, showing the streets of the given town. We have what we call a strip map. As I showed you, this one here, we call the strip map. It shows the straight route from one town to another with the numbers or distances allocated on the right and the left-hand side. This is a strip map or a strip chart, some people will call it, or you can call it a route map. You see? A route map. Then we come to, you know, question number, you see, next year. So let's see a next year B, and next year B. No, this is a next year A. This the district central map. You see how it looks like. Now this suitable word, this suitable type of the title for this, it will be a street map, where it shows streets of a given town, which is a section in Cape Town. A section in Cape Town, I think it's called the Green Point. All right. Central Business District, which is called CBD. All right, that's what it stands for. Then the scale, what kind of scale are we looking at? This kind of scale, we call it a ratio scale. This is a ratio scale. Others call it a number scale, which is okay. You can also call it numeric scale, which is okay. All right. Then The other kind of scale is called a bar scale or a line scale. All right, now we go to question number 3, measurements. Measurements, we go back now to our area, perimeter, measurements. So look at that. Calculate the perimeter. They want the perimeter, and you know very well that perimeter is the total distance around a given shape, but they want it in meters. Make sure your answer is in meters. If there are any measurements that are not in the same units, please you change them to look like the others, not to be the same with, to have the same units with the other measurements given to you. All right, there we go. Now, look at these formulas here. This is for rectangle. This is for rectangle. And the one on top, this is for it's a circle. The moment you see radius, just know it's a circle. The moment you see length and breadth, you just know it's what? It's a rectangle. Because a square, all sides are equal, so you will have side. All right, there we go. You look at this. This is a mesh. So the moment you look at this, also it's it will be determined by perimeter. Okay, you look even here outside perimeter. It's a perimeter. Then you look at that scale. You see, there we go. We look at volume measurements. We have volume. We have two things that we need to know: volume versus capacity. Yes, these two are the same. However, one is in real life, the other is in the calculation part of life. You understand? Volume, space occupied by a given, we say space taken up by a given object, whereas capacity, it's how much can an object contain. How much can an object contain? How much can it hold? Together, that's the capacity. Volume, how much space does it take? When I put it in a certain corner, how much space does it take? Both upwards and downwards. You understand? That is the volume. Okay. Now this throws back, takes us back to this is the BMI charts. You understand? And BMI stands for body mass index, used to tell the health status or weight status of a given person. You understand? Remember very well that BMI will always equal to your mass in kilograms. Yes. And the height in meters. The height has also to be in meters, but you have to square. This is supposed to be squared. The height has to be in meters, but it's what? Squared. Another thing I would like students to learn, the same way you learned DSTV, I'm talking of this, DSTV, this triangle here, the one that we use for maps and distance. The same way you can also make sure that you remember BMI. So it will be that's how we shall get the formula. So if you need BMI, you take mass divided by height squared. When you're looking for height, it will be mass over, but then we'll need to look for the square root. Then if you're looking for, when you're looking for mass, it will equal to BMI times what? H squared. All right, there we go now. This is what we're talking about. This is the formula for BMI. All right, answer accordingly. Okay, Mr. Johnson, the family trip we're getting from Golden Gate in Free State. The family arrives at Brandfish International Airport, Bloom. They hire a car and drive to, this is a planning. This is a trip or maps. The moment you see the map, think of it also the scale. What's the use of a scale? It's to change the the diagrammic dimensions to real life, or the real life dimensions to fit on Earth, or to fit in the real life. The real life dimensions to fit on paper, we need a scale. Okay, this kind of map is called the this is a timeline, eh? It's a timeline. Check this again. All right, we shall be looking at question number 4. Question number 4, Question number 4, they tell us, question 4, you still expect to see maps and plans. Expect to see maps and plans and measurements integrated. Now, what we think of, what we know here now, for example, they might give you a floor plan. Now we need to know the area of a given what? Bedroom. On this floor plan. You see what I'm talking about? That will call in measurements. Please don't forget the units. Units are important in paper 2. Units are important. Why? We are dealing with measurements. We are dealing with measurements. You understand? Even when you convert, I have converted centimeters to meters. The answer has to be shown in units. The answer has to be shown in units. All right. Measurements, we need units. Please take note of that. Another thing, if the question is 8 marks, don't get scared because the question is 8 marks. All right? Don't get scared because the question is 8 marks. No, you will have to get some marks from there. You understand? We take examples of, for example, if they ask you for, how is it called? You remember we look at area to be painted, what? So if you get the area, you get a mark. If you add all the areas of the rooms, you get a mark. You understand? You give your answer with the units, you get a mark. You understand? That is it. Don't get scared. Don't get scared. Give it your all and you'll see the results. All right. We're looking at question number 4. Now, another thing is that when we look at measurements, we shall be looking at conversions. Remember telling you about that? Conversions. Remember, we have 2 systems for conversions. We have the metric and the other one, it's what we call the imperial. I usually say metric, it's the new, whereas the old is imperial. New, but metric, you know it very well. Metric, we shall need to know our kilometer, meter, centimeter, millimeter. You understand? Yes, then we shall look at measurements. You measure the length. This will be in using instruments there as rulers. Remember, this one here, usually you apply it when you use the scales. You understand? From measurement on paper, then you want it to become measurement in real life. You remember that? So you definitely have to measure. Either if it's if you're using a bus scale, you measure the bus scale. You need to measure the distance between the 2 towns. If you have a scale that's a line scale, you use a line scale. Then we shall have weight. Weight, this is when we look at kilograms. grams, and milligrams. All right, kilograms, grams, and milligrams. All right. What I want you to remember is that when it comes to measurements, you will have to remember, especially the metric. We shall have to remember the metric. We shall have to remember the metric method, whereby we do what? Look at that. We said metric, we have kilometers, followed by meters, centimeters, and millimeters. In between these, we have the first one, the largest is 1,000. It reduces by 1 0, it becomes 100. Then it reduces by 1 0, it becomes 10. We reduce. So in between kilometer and meter, we have 1,000. In between meter and centimeter, we have 100. Between centimeter and millimeter, we have 10. Another thing that you have to remember here, it's big to small, we shall need to multiply. Whereas small to big, we shall need to divide. You understand? So simply meaning, if you're leaving kilometers to changing kilometers to meters, we need to multiply. Why? You're from a big unit to a smaller unit. Still, it goes on and on. Here also, you're going to multiply. Here, you are multiplying. But then this section here, you multiply by 10. This section here, you multiply by 100. This section here, you multiply by 1,000. So the other way around, small to big. That's it. Now we've been moving from left to right. Then if you're moving from right to left, this is when you need to divide. Left to right, you need to multiply. Right to left, you need to divide. Together. So this is left to right. And this is right to left. This has to be in your head. You have to know it off head. All right. Volume or capacity. These ones we shall see them. These are under still also measurements. These are measurements. And we said volume. This is mathematical. Volume. Then this is in real life. Liters, kiloliters. As temperature, we have 2 or then perimeter, total distance. That's what we should know. So total distance around a given. Then area. Area is the surface. You can say surface enclosed in a perimeter. I don't know whether it makes sense. So we have such a shape. You see that? Then when A, B, C, and D, if I move from A to B, then I go to from B to C, I move from C to D, then I come back to the same point A, we're covering AD. I have covered a perimeter. But then if I play from inside, this inside here, if I come and I cover this white part inside the perimeter, I'm covering what we call the area. So area is inside, perimeter it's outside. Around is the perimeter. Inside is the area. Surface inside there. How much can I cover? How much can be painted? How much? You understand? Then volume, we said this is a space and an object occupies. The space an object takes up. Then capacity, we said the amount that is carried. How much can this bottle carry? That amount, we call it the capacity. To which extent can this bottle carry? All right, then time, we shall see time. There are 2 things we need. We have the 24-hour system and we have the 12-hour system. Some people call this the digital format. And this one, they call it the analog. You understand? Here we have the AM and the PM. Here we have nothing like that. All right? We have nothing like that. Keep in mind what we need. Now, maps, plans, and scales. What we expect to see in this format is sitting plan, a layout of a building, which is a floor plan, the layout of stores. Okay, yeah, this is also, it can be a floor plan, the layout of buildings, and sport field. Yeah, this is true also. And sitting plan in cinema, I talked about the stadiums, examinations. We can check on this and you see the sitting like this. This is a sitting plan, but this is for a stadium. How do people, which number is someone going to sit? Which place will the person be positioned? All right, that is it. Okay, then we look at the street maps. I showed you this already in the next chapter. This street map, why? It has streets. These are streets inside. You see? You look at that. Look at all these. These are all streets. So it becomes a street map. You see that? Then we come to the route map. The route map will be, you see, the route map, it can take over this place here. Or we have the street maps that's done, then without a grid reference. We have what we call the grid reference. Terms that you have to remember in measurements. We have grid reference. Grid reference, that's what you should not remember. Then grid reference, you should remember that. Then we have what we call the general direction. General direction. I'm talking of the map now. General direction, we need to know general direction. We need to know we need to use the what? The compass. General direction, we are looking for north, south, east, northeast, northwest, southeast, southwest. We are using. Then the grid reference is when we pick a box where a certain town is found. If this is 1, 2, 3, then we have A, B. You understand? And there's a town here. That's the grid. Then the grid reference will become 2B. Or you can write it as B2. You see that? Okay. The street chart I've just showed you in one of the questions here. It was question 1. That's how we know the street chart. This one here. This is what we call the street chart. Street chart, or you can call it a route map because it shows a route. Then we have showing this is a portion of a road. Okay, elevation. Elevations are now okay. We have 2 elevations. We have the ones for the house, whereby you show the wall of the house. It shows the windows, the wall. Now, leave alone the plan, which is already drawn down, and someone does, leave alone that. What about the wall? The wall, it becomes elevation. This is the floor plan. Then these days is what we call elevation maps. Elevation maps are the ones that show how people covered. This is comrade marathons. All right, comrade marathons. The maps like this one here, it's an elevation map. This is an elevation map. This is how an elevation map looks like. It's elevating. People are running. Someone goes up, and the elevation, because the distance also is what? Increasing afterwards. This shows that they're coming to an end. They have to decrease to, it's called acceleration and deaccelerate. So they are deaccelerating when they are coming down. Accelerating, you are pushing forward. Okay. That is it. Then the residential also state that this might give you a map showing a lot of what houses. Then we have what we call models and packaging. This comes in question either 5 or 4, as we looked at, but mainly probably 5. This is question number 5. Here we shall look at packaging, assembly. All right. Packaging, we find out how many items fit on the long side, how many items fit on the short side. Then, for example, if here we have, we say we need 4 items, and on the short side we need 3. So the first layer, how many will they be? We shall say 3 times 4. So this layer will take 4 items. You see how we get those numbers there. All right. Assemble. To assemble, this is when we follow the plan. Assemble, this is when we follow the plan, and we like this. This is assembly. You understand? This was they were assembling it's a bed. Step 9 of 10 of the assembly instructions for the King's train bank beds with a slide with a slide as shown below. You see that? This is but how do you assemble it? So that will become our question today. All right. Thank you very much. And this brings us to the end of our prediction. Wish you the best and keep in touch. Bye-bye.
Question 1. Enter the information in the map below and answer the following question. Now the questions that follow. The Suez Canal is an artificial sea level. The Suez Canal is an artificial sea level waterway running 193 kilometers between you take note of these numbers. Never know, you might know. It's between Port Said in the north and Suez in the south. Suez Canal offers the shortest route measure ships carrying cargo around the world. Construction of Suez began in September and was first opened in 1969. When they first opened, 8 meters deep, 200 meters wide at the bottom, and 61 to 91 meters wide at the surface, to allow ships to pass each other. Passing bays were built 8 to 10 kilometers. We are highlighting numbers because we might need to deal with them. Here's the diagram, here's the map. Identify the country that borders the Suez Canal on the western side. So first and foremost, look for the Suez Canal. The Suez Canal is here. The Suez Canal is here. So this is the north, and we need the west. So they are saying identify the country that borders the Suez Canal on the western side. The western side, it's the country, not the continent. So it's Egypt. So you write down the names of the continents. The names of the continents separated by the Suez Canal. First and foremost, we have continent. We have what? Africa. Then when you come here, we have Asia. Africa and Asia. Identify the sea that is found on the southern side of the Suez Canal. So here,
193 kilometers between the port side north and the street south. So this is the distance that you're looking at. So they said you want it in meters. So it will be 193. Oh, they said in kilometers. It's fine. 193 kilometers. Mention one advantage that the ships have when using the Suez Canal. They said